All right, today's lesson is factoring methods and solving by factoring. You guys have already done 2 days of factoring homework, hopefully, but here are some guidelines for factoring completely. You're going to have more than one thing going on at a time. First of all, you want to factor out the GCF. That's the greatest common factor. You're looking to see if there are anything that all terms have in common that you can take out. Then you're going to look for special cases. If there are 2 terms, you're going to look for dots. That's a difference of 2 squares. If there are 3 terms, you're going to check and see if it's a PST or a perfect square trinomial. If it's a trinomial that's not a PST, you're going to try and factor it into 2 sets of parentheses, binomials in each parenthesis. If it has 4 terms, you're going to factor by grouping. And once you're done factoring, you want to make sure that each factor is prime. What that means is that in each set of parentheses, the terms have nothing in common. Lastly, you can check your work by multiplying the factors back out to see if you get what you started with. Okay, we're going to do 2 examples together. The first one, go ahead and write it down. It's v to the 4th minus 5v squared plus 4. First, we check for GCF. They do not all have anything in common. It's a trinomial. It is not a perfect square trinomial. So we move on and try and factor into 2 parentheses. 2 things that multiply to be v to the 4th. We're going to try v squared times v squared. This tells me my signs are the same. This tells me they're both negative. And then 2 numbers that multiply to be 4 and add to be negative 5 are 4 and 1. At this point, we look and see, are we done? Looking at each individual set of parentheses, I have 2 cases of dots, difference of 2 squares, 2 perfect squares being subtracted in each case. So this set of parentheses breaks down again into dots, v plus 2 and v minus 2, and this set of parentheses breaks up again into v plus 1, v minus 1. I now have all sets of parentheses prime. They have nothing in common. There are no special cases. I am done. All right, second example. 3xy squared minus 27x to the 3rd. First thing is looking for a GCF, a greatest common factor. Both terms have a 3 and an x in common. Once you take that out, you're left with y squared minus 9x squared. Now you look and see what you're left with. Is there anything I can do with that? It's 2 terms and it happens to be dots, difference of 2 squares. So I break that up again into y plus 3x and y minus 3x. Do not forget to include the GCF you took out initially in your final answer. All right, the next thing that we're going to be doing is solving by factoring. When you are solving by factoring, it uses what's called the zero product property. That says if A times B equals 0, that means 2 quantities being multiplied. If you know their product is 0, then one of 2 things is true. Either the first quantity equals 0 or the second quantity equals 0. Either A or B has to equal 0. We use this property when we are solving by factoring. First thing you want to do is make sure your equation is set equal to 0 and that it is in standard form. Your exponents are in decreasing order. Then you want to factor that resulting polynomial completely using the guidelines that we did at the beginning of this lesson. Then you're going to set each individual factor equal to 0 and solve accordingly. We're going to look at 2 examples here and then we'll be done. First example. Your first example is 18y to the 3rd plus 8y plus 24y squared equals 0. It's already set equal to 0, and it's not in standard form. So the first thing I'm going to do is put it in standard form, exponents in decreasing order. Then I'm going to factor completely. Remember for the guidelines from above, you look for a GCF. They all have a 2y in common. Take out a 2y, and you're left with 9y squared plus 12y plus 4. Now I look at the resulting trinomial, and this happens to be a PST, perfect square trinomial. My first and last terms are perfect squares, and the middle term is the product of these square roots doubled. So to factor that, if you remember the shortcut from last week, square root of 9y squared is 3y. Square root of 4 is 2. Both of my signs are the same, and they're both positive. And again, don't forget the GCF you took out initially. This is now factored completely. I set each of these factors equal to 0. I have 2y equals 0, and I have 3y plus 2 equals 0. I'm not going to write it out twice because it's the exact same equation. Solving for y, we get y equals 0 here, and we get y equals negative 2 over 3 on this one. If you subtract 2, divide by 3, y equals negative 2/3 and 0. And the last example, almost done. Before we start this last example, let me tell you the phrase of the day. It is factoring is fantastic. Why is factoring fantastic? Because it is. You don't need to know why. It just is. Alright, so the first thing we want to do here is get the equation set equal to 0 in standard form. So we need to subtract 13u to the third from both sides and put it in standard form. It's going to look like this. U to the fifth minus 13u to the third plus 36u equals 0. Factoring completely, we want to look for a GCF. They all have a u in common. So you take out that common u, and you're left with u to the fourth minus 13u squared plus 36. Looking at the resulting trinomial, it's not a PST, but I can still break it down into two parentheses. Don't forget your GCF you took out initially. This breaks down into u squared on both sides. Two numbers that multiply to be 36 are 9 and 4. My signs are the same, and they're both negative. We are not done. This is not factored completely. We have two cases of dots here. Okay, so this breaks down into two parentheses. You get u plus 3 and u minus 3. This breaks down into two more parentheses, and you have u plus 2 and u minus 2. Again, don't forget that GCF. It's set equal to 0. Now we have several factors we need to set equal to 0. We have u equals 0, u plus 3 equals 0, u minus 3 equals 0, u plus 2 equals 0, and u minus 2 equals 0. These are all very simple equations to solve. You get u equals 0, negative 3, positive 3, negative 2, and positive 2. And there you have it. Enjoy!